Guys, welcome to the localhost lab, and today we are looking at another creational design pattern. So a quick recap. So what is creational design patterns? So they are patterns which deals with object creation mechanisms. What is the goal? To create objects in a very flexible, reusable and controlled manner. That's why we use creational design patterns. We have already covered singleton design pattern. In this video we'll see what is factory design pattern. So we have already covered this. We will see factory pattern in this video. So let's start factory design pattern. So the idea is to create the objects without tight coupling. So factory design pattern is a creational design pattern, and we are encapsulating object creation logic. Now we are promoting open closed principle. So if you have watched my video on solid principles, then you know ki O stands for open closed principle. That is, your class should be open for extension, but it should be closed for modification. So this is what we try to achieve through this design pattern. We'll get a deep understanding with a code example. Let's move forward. So what is factory pattern? So this pattern, it provides an interface for creating objects while allowing subclasses of factory classes to decide which object to instantiate. So there are a lot of keywords that I have used, but it will all make sense when you see at the code. So if let's forget about design pattern. If we want to use objects, how do we create objects? By using new keyword. So without factory, the object creation, it is very tightly coupled. What is tightly coupled? When two services are very tightly coupled, they are not, there's no abstraction. And for some scenarios we have to use multiple if else, and this is very hard to extend. We have to modify our client code, which will break the OCP principle, and this is very difficult when we test. Why? Because we are modifying our client class. But with factory pattern, we will achieve what we want to achieve, which is loose coupling, and we are creating our object creation in a centralized manner. So this is very easy to extend, which we want to achieve, and the testability, it's very easy. So let's understand this pattern with a problem statement. So we have been given a payment processing system. So my application, it supports different payment methods like cards, credit card, UPI, net banking. So whenever a request arrives, it could be of any type: UPI, card, net banking. So the system must decide which processor to create or which one to use, which object to instantiate. And these are some real world use cases. So this problem statement we'll see, but before that, let's also see where this factory design pattern is used. It's mostly used in bean factory application context. And if you have ever worked on payment systems, so we have different payment gateways: Razor-based, Stripe, PayPal. So we basically, for these use cases, factory design pattern is used. There are other cases as well, other examples as well, but I have listed only the ones that I have worked on. So now let's look at the bad code design. So here, let's see. So I have a service class, which is this payment service class. Now here you see we have a method called process payment, and here there are if conditions. If so we are getting an argument in this, which is payment type. So it could be of UPI, card. In future, if you want to integrate another payment method, you can do so. So for now, if it's UPI, we have to call this UPI payment processor. So whatever logic you want, you can have it here. If it is a card, we can So we are creating its object and then we are calling its process method. Similarly for card, payment process. For now I've just kept this, so we can call it. Suppose if you want to add another payment method, let's say else if, let's see, we'll add another payment method called as card. Okay. Now tell me something, are we modifying this service class of ours? We are. This is breaking OCP principle. We are modifying. If we want to integrate another payment method, we have to write another else if condition. So you are getting what is the exact problem statement. We are breaking the OCP principle, and this is very tightly coupled. UPI may we are calling this its exact concrete class. Card, for card we are calling its concrete class method. So this is very tightly coupled. So this is a very bad design. Now this is where factory design pattern comes in. So how we can transform this code using factory design pattern, which will make it a good design. Let's see. So I'll close this. So what here I have done is I have created an interface, which is the payment processor. Now this process payment, this payment processor, it will be implemented by card. So the card will have its own logic. It will be implemented by UPI. It will have its own logic, right? And then in service class, see here, and then I have created one factory class. So what this does is, now here you see we have a get processor. So we are passing a payment type, and based on if condition we are returning the actual concrete class object. Okay. Now in a service class we are using this factory. Okay. We have instantiated this factory, and then based on that factory we are calling the processor. Once we have the implementation, so this interface is implemented by UPI, card, in future maybe wallet, net banking, anything. We don't have to change our service class anymore. Correct? Now suppose if I want to add another payment method, how will I do it? I'll simply copy this. See, whatever changes I'm making in my factory class. Okay, I'm not making any changes in my client class. So this wallet payment processor, I've already created this class, and it is implementing the same payment processor, and I will simply return this. Now whatever payment type comes, from the factory I can get that payment processor implementation, and I'm calling its process payment. So this is a good design. We are not modifying our service class anymore. We are not messing up, or we are not touching our service class anymore. So I hope this is clear to you why we need this factory design pattern. So thank you for watching, and if you have any doubts or any queries, you can ask me in the comments.